So welcome back, learners. This is LANGET KCSE 2024 paper 2. So I want us to handle this paper and I want us to look at the first question. So if you're watching this channel for the first time, you have to subscribe, like, share, and our first question here starts with the periodic table, where you are asked, the grid below represents the periodic table. Study it and answer the questions that follows. The letters do not represent the actual symbols of the elements. Now, when you deal with the periodic table, there is one thing you must know about the periodic table. When you're dealing with the periodic table, you have to know that your answers, or you have to study this table very well so that you know that whatever you are dealing with is, you know that the groups must be written in Roman numbers and the periods must be written in either the number itself, for example, period 3 or period 3. Just write 3 in full. But for groups, they have to be written in Roman numbers. So if you're asked in this question, for example, which element exists naturally as a diatomic gas? So you must ask yourself, what do we mean by elements existing as a diatomic gas? What do you mean by elements existing as a diatomic gas? When we talk about an element existing as a diatomic gas, the element that can exist, when you talk about diatomic gas, you're talking about something like oxygen. If you look at something like oxygen, for example, just going to note it here, oxygen is usually written as O2. O2. That is how oxygen is usually written. So that means you have to look for a gas that is having the same format as oxygen. And when you look at this table, the only gas that has the same format as oxygen is this T. Because this T is chlorine, and chlorine is usually written as Cl2. So the gas that exists as a diatomic gas is gas T. So that one has to be noted. The gas that exists as a diatomic gas is gas T. Note that. Okay. Now once you note that, then we now proceed to this other question here. I'm just trying to see that I increase the font size so that it becomes a bit visible to you. So I'm just going to increase this font size here. Yeah, that's at least better. And then now we come to a gas that exists as a monoatomic gas. A monoatomic gas, most of monoatomic gases, they belong to this group here. This is group 8. Okay, so most likely the monoatomic gas is going to be gas S. So just come here and write gas S. Just write there gas S. So I'm trying to highlight so that it becomes very visible, so that you can see very well. So that is gas S. And then now we come to this other question here. You are asked, write down the formula of the most stable ion of K and its electron arrangement. Look at K. K is number what in the periodic table? 1. You just count from here. This is number 1, number 2, number 3, number 4. So that means this K is equal to number 4. And because K is equal to number 4, you can write the electron arrangement, which is 2 to 2. Okay? So you've been told to write the formula of the most stable ion. That means for this K to be stable, what is it going to do? It's going to lose these 2 electrons. It's going to lose these 2 electrons here. And when it loses these 2 electrons here, it means, when K loses electrons, it's now going to be positive. Because when an atom loses electrons, it forms a cation. That means it's going to be K. It's going to be K2 positive. K2 positive. That is now going to be the ion, and its electron arrangement is now going to be 2. The electron arrangement is now going to be 2. Because it has lost these 2 electrons. I hope that is well understood. Now when you go to question C, how does the atomic radius of G and L compare? Look at G and L. G and L. There's one thing that you must know, learners. When you go down the group, the atomic radius increases. But when you go across the period, the atomic radius decreases. And there's a reason. When you're going down the group, the atomic radius increases because of increase in number of energy levels. But when you go across the period, atomic number decreases due to increase in number of protons, which increases the nuclear force of attraction. So if you're told to compare the atomic radius of G and L, you look at the G and L. G and L. So that means I've said as you go down the group, the number of atomic radius, the number of energy levels are increasing. That means L has a larger atomic radius than G. Okay? So you'll come here and say L has a larger atomic radius than G. A larger atomic radius than G. And you'll say this is due to increase in number of protons. This is due to increase in number of protons. Increase in number of energy levels, not proton. Number of energy levels. Down the group. That is very important. So once you do that, learners, so I'm going to highlight this so that you can also see it very well down the group. So this is now going to be our answer for this particular question. Now, when you go to the next question you asked, how does the first ionization energy of G and L compare? In short, you're being asked G and L. You know, when you're looking at the first ionization energy, of course, L, when you look at the first ionization, this is the ionization energy that is required to remove the first electron. So unaulizwa like kati ya G na L ni gani inahitaji you're asked which one has a, how does the first ionization energy of G and L compare? Of course, L will have a lower first ionization energy because it has a larger atomic radius. That means the outermost electron is further away from the nucleus. So you're going to expect that L is going to have a lower first ionization energy than G. So we just come here and note L has a lower first ionization energy than G because its outermost electrons are further away from the nucleus. So that is going to be a reason for this particular question. You highlight that. Just going to ensure that it's reddish in color so that you can see it very well. Then we come to this other question down here where you are now asked which two elements will react more vigorously with each other. You want to see the element that will react more vigorously with each other. If you meet this question where you are asked which two elements will react more vigorously with each other, there is one trick that you must know. For you to get the element that reacts more vigorously with each other, you go to group 1 at the bottom. Group 1 at the bottom and group 7 at the top. So we have started with group 1 at the bottom. So we'll start with group 1. Group 1 at the bottom. And group 7 at the top. And group 7 at the top. What do I mean by that? So we'll come to group 1. This is group 1 at the bottom. Which element is at the bottom here? It is element L. Which element is there? Element L. And then you come to group 7 at the top. Which element is at the top? Group element T. So that means the element that is there on group 7 at the top is element T. That will be element T. So if you are asked which two elements will react more vigorously with each other, you go to group 1 at the bottom and group 7 at the top. That is element L and element T. So your answer is going to be L and T. L and T. L and T. I've told you how you can know that very well, okay? So let me highlight this. I hope that has been well understood, learners, up to there. I hope you are understanding something. So I'm going to do another successive video on this. So if you're watching our channel for the first time, kindly take time, subscribe, like, and share. I'm doing another video on this LANGET paper so that you learn more about this. Thank you very much.